Okay, we are now looking at question 1 of complex numbers tutorial 9b. First question, we are given argument of a plus ib equals to theta, where a and b are greater than 0. Based on this information, it is clear to us that our complex number of a plus ib lies on the first quadrant. So at this moment, what you can do for yourself is you can identify where this complex number is. So we construct an Argand diagram, and in this case, in identifying the position of A and B, my advice to students is that try to select a value of A and a value of B such that their values do not suggest to you that they are almost equal, so that later, if the a and the b were to become a real or the imaginary part of a new complex number, it is easy for you to see the relationship of it with respect to this original complex number of a plus ib. So, we plot this point, and this point is of coordinate of ab, so that is our complex number a plus ib. And question tells us that the argument of it is theta. So let's construct a straight line connecting to our center, and the angle over here is theta. So let's take a look at our part 1. Part 1 is asking us to find the argument of negative a plus ib. So we will need to now locate where this complex number is. For this particular complex number, it is clear to us that its real part is negative a, so therefore it will be somewhere on the left of your imaginary axis with a distance of a on the left of it. Imaginary part of it is b, so it will be the same imaginary part as of the original complex number given, and with that we are able to locate that this is where our new complex number is, with coordinate negative a, b. So if we want to find the argument of this complex number, meaning from the diagram, we will need to measure how big this particular angle is. And to find this particular angle, we may need the help of the adjacent angle right here. And you can see by the property of reflection, you can easily conclude that this particular angle is theta. So therefore, without much difficulty, we can now say that the argument of negative a plus ib is equals to a pi minus a theta. And that concludes our part 1. Let's move on to our part 2. Part 2 over here, we are looking at the new complex number of negative a minus an ib. So we can still use back the same diagram. So negative a, you can see that it is right here. As of negative b, it will be somewhere down here, below your real axis. And therefore, our new complex number, it is somewhere at the third quadrant. So, should we want to find the argument of this complex number, it is clear to us now that we will have to make a clockwise rotation from our positive real axis, and this particular angle, you can see that it is of the same magnitude as the angle that you have found in your part 1. But in this case, because it is a clockwise rotation, so therefore the argument of it has to be in terms of a negative value. So answer for part 2, argument of negative a minus ib, it will be equal to a negative of the magnitude of the angle from part 1, which is pi minus theta. And therefore, we can conclude that the answer is theta minus pi. Let's now take a look at part 3. Now, part 3, you can see that the new complex number that we are finding is b plus ia, and it's clear to us that the real part and the imaginary part of the original complex number has changed places. So how are we going to see this change in our diagram? Let's now take a look. if again I identify my original complex number of A plus IB to be over here, then now if I were to like to identify where my new complex number of B plus IA is, so now the real part, we need to measure B units. Now in this case, you could see that just now our B unit is this long. So therefore now we will try our very best to label our B of the same length but on the real axis. Now in a similar manner, you will then say that my A will be somewhere here at the imaginary axis. And this leads us to see that the new complex number of B plus IA is still on the first quadrant, but it is somewhere on top. And therefore, if we would like to find the argument of this new complex number, it is clear to us that the argument is of the angle this big. But what is this relationship with the original complex number that we are dealing with? Now you can see that this particular angle here is equal to theta. Again, it is by the property of symmetry. So for our part 3, the argument of B plus IA, you can easily observe that it is equals to pi over 2 minus theta. And that concludes your part 3 of question 1.